In the fast-moving landscape of 2026, the paradigm of automation has shifted overnight. For years, we relied on complex node and wire setups and tools like n8n to simulate intelligence, but Anthropic's move into managed agents has effectively moved the orchestration loop from the developer's responsibility into the model's core infrastructure. We are witnessing a 10 billion shift where the heavy lifting of state management, tool calling, and error recovery is absorbed by the LLM provider. Most senior developers are realizing that the manual overhead of building loops in external workflow engines is becoming a form of technical debt. If you're still manually mapping JSON outputs to node inputs for every single step, you're building a fragile legacy system in a world that has moved to autonomous orchestration. This lecture is designed to strip away the hype and analyze the cold reality. The era of manual workflow automation is ending, and the era of managed agentic loops has begun. By the end of this course, you will have a clear framework to determine which parts of your stack are now obsolete. Let's look at the efficiency gap. In a traditional n8n workflow, creating a simple research agent requires at least 10 distinct nodes, custom JavaScript for data parsing, and constant monitoring for API timeout errors. If an external API schema changes by even 5%, your entire n8n workflow breaks, requiring hours of manual debugging. In contrast, Claude managed agents utilize native tool integration where the model itself understands the tool schema and handles the retry logic internally. We are seeing latency reductions of up to 40% because the data doesn't have to travel back and forth between an external orchestrator and the LLM for every single reasoning step. Senior architects are now calculating the cost of maintenance via the cost of inference. When you factor in the developer hours spent fixing broken nodes in n8n, the managed agent approach isn't just faster, it's significantly cheaper at scale. The question is no longer, can we automate this? But should we still be the ones managing the loop? As a senior developer or architect, your job isn't to chase every new tool, but to build resilient systems. This lecture provides a cold, analytical framework for the agentic maturity model. We have to judge when to migrate your existing n8n workflows to Claude-managed agents, and when it's actually safer to hold the line. We will evaluate 3 critical pillars: orchestration overhead, state persistence requirements, and tool calling latency. If your workflow requires high-frequency reasoning and multi-step tool usage without human intervention, sticking with n8n is a strategic mistake. However, for complex legacy integrations that require a GUI-based human-in-the-loop interface, n8n might still hold a niche. We are moving from the world of if this then that into a world of goal-directed autonomy. In the following chapters, we will dive into technical specifics of how Claude Code and managed agents are dismantling the traditional automation stack. This is about more than just tools. It's about your survival as an architect in an AI-native world. In the early days of automation, tools like Zapier introduced us to the linear trigger action model. It worked for simple tasks, but as business logic grew, we migrated to node-based platforms like n8n. These tools allowed for complex branching and data manipulation, creating what we call spaghetti workflows, where a single automation could contain 50 or more interconnected nodes. While visually impressive, these legacy systems are fundamentally rigid. They rely on hard-coded paths defined by the developer, which makes them incredibly fragile when faced with the unpredictable nature of large language models. In a world where AI needs to reflect, pivot, and retry, these static graphs act more like a cage than a tool. We are hitting the ceiling of what predefined nodes can achieve in an agentic era. But as these graphs grow into unmanageable monsters, a more fundamental flaw emerges regarding how they handle information. Let's see why non-deterministic tasks break them. The core problem with using n8n or Zapier for AI agents is state management. In a traditional workflow, the data flows in one direction. If an error occurs, the process simply stops or follows a basic on-failure path. However, AI agents operate through non-deterministic reasoning. They might need to try a different tool, re-examine a file, or correct their own code. Implementing this in n8n requires creating infinite loops and complex if conditions for every possible edge case, which is a nightmare to maintain. You end up spending 90% of your time building the infrastructure for error handling rather than focusing on the agent's actual capability. This manual orchestration is where the friction lies. The tools we built for deterministic software are being forced to manage probabilistic intelligence, and the seams are starting to show. Beyond just the logic, there is a hidden financial and operational tax you're paying right now for this manual management. Maintaining a local agent runner or a complex n8n instance isn't just a technical challenge, it's an overhead trap. When you run agents through external orchestrators, you deal with massive context window overhead. Every time a node passes data to another, you are often resending large chunks of state through APIs, leading to token waste and high latency. Furthermore, the cost of local compute the servers you manage to run these containers adds up. Compare this to managed agents where the provider handles the environment. In traditional setups, you are the sysadmin for your agents. You manage the Docker containers, the Python environments, and the tool calling permissions. This hidden tax is what kills the ROI of AI projects in production. We need a way to offload this complexity to the infrastructure layer itself. What if we could delete all those infrastructure nodes entirely? That's where Anthropic's new architecture comes in. Managed agents represent a paradigm shift. Instead of you building a bridge between the AI and the tools, Anthropic has moved the tools inside the agent's loop. In this model, the infrastructure, including the file system, code execution environment, and even browser access, is handled natively by the Claude API. You no longer need to build an n8n node for write to file or execute Python script. Instead, you simply tell the agent what to do, and it interacts with its own managed sandbox. This internal loop reduces the latency caused by back-and-forth API calls and ensures that the agent has a consistent, high-fidelity view of its environment. It's an abstraction layer that treats compute and storage as first-class citizens of the model itself, not as external plugins. It's not just about convenience. It's about giving the AI a safe, sandbox playground to actually execute code and see the results instantly. One of the most critical advantages of this shift is security through sandboxing. If you've ever tried to let an LLM run code on your local machine via n8n, you know the security risks a single RMRF command could be disastrous. Managed agents solve this by offloading code execution to the provider's highly secured, ephemeral environments. When Claude Code or a managed agent executes a script, it happens in a container that lives for seconds and has restricted network access unless specified. This allows for massive scalability without the developer needing to manage a Kubernetes cluster for agent workers. You get execution as a service. This infrastructure doesn't just live in a web UI, it's seamlessly integrated into your local terminal and production API, creating a unified developer experience that n8n simply cannot match. To wrap up this evolution, we are moving from orchestration as a separate tool to orchestration as a feature of the LLM. Managed agents unify the developer experience. Whether you're using the Claude Code CLI for local development or deploying an agent via the API, the underlying infrastructure remains identical. This consistency means your agents are more reliable, easier to debug, and significantly cheaper to run at scale. We are witnessing the death of the middleware era for AI. You no longer need 100 n8n nodes to make an agent act like an agent. You just need a well-defined goal and a managed endpoint. Managed agents seem superior on paper, but how do they actually hold up against n8n in a real-world stress test? We'll settle that head-to-head comparison in the next chapter. In the world of 2026 automation, latency isn't just a nuisance, it's a failure state. When we look at a self-hosted n8n instance, every single node transition involves an execution overhead. If your agent needs to check a database, search the web, and then summarize, n8n orchestrates these as discrete steps with network hops between the workflow engine and the LLM. In contrast, Claude managed agents operate Anthropic's native compute environment. The tool calling happens in a tight internal loop. By eliminating the HTTP round trips required for every node execution in n8n, managed agents achieve a 40% reduction in end-to-end task completion time. For real-time applications like customer support bots, this difference determines whether a user feels they are talking to a human or a lagging script. But speed is only one part of the equation. How does the system actually remember what happened 3 steps ago? Question: is speed the only metric that matters? Let's talk about the brain of the operation memory. The biggest headache for any backend developer using n8n is state management. To keep a session alive, you typically have to wire up an external Redis or PostgreSQL database and manually map session IDs to every node. Claude managed agents introduce native session precedence. This means the agent maintains the state of the conversation, the variables retrieved from tools, and the reasoning chain internally without you writing a single insert into DB node. By 2026 standards, we expect our infrastructure to handle the boring parts like memory automatically. In a managed agent setup, the context window is managed intelligently, prioritizing relevant historical data while purging the noise. This native memory handling reduces the state tax that often bloats n8n workflows into unreadable spaghetti diagrams. Payoff memory is fine, but can these agents actually complete a 10-step reasoning chain without hallucinating? The benchmarks tell a different story. Reliability is where the managed part of Claude agents truly shines. In traditional n8n workflows, a single failed node, perhaps a temporary API timeout, can crash the entire execution unless you've built complex error handling loops. When we benchmark multi-step reasoning tasks, n8n's success rate often plateaus because it follows a rigid, deterministic path. If the LLM generates a slightly malformed JSON, the n8n JSON parser node fails. Claude managed agents, however, use an autonomic recovery loop. If a tool call fails or returns unexpected data, the agent can reason about the error and retry or adjust its strategy within the same execution cycle. This leads to a significantly higher task completion rate in messy, real-world environments where APIs are flaky and data unstructured. Teaser architecture is one thing, but your CFO cares about the bottom line. Let's crunch the numbers on the invisible tax. Let's talk about the total cost of ownership, TCO. Many teams choose n8n because the software itself is open source or has a lower entry price. However, you aren't just paying for the license. You're paying for the EC2 instances, the maintenance of the Docker containers, and the engineering hours spent on workflow janitorial work. Claude managed agents have a higher per token or per session price, but they effectively zero out the infrastructure management costs. In a 2026 enterprise landscape, the bottleneck is rarely the API cost, the cost of senior developers spending time fixing broken webhooks. When you factor in maintenance, a managed agent setup often becomes cheaper at scale because it requires fewer babysitting hours from your DevOps team. Question: is a cheaper API always better if it takes 40 hours of engineering time to set up? This leads us to the developer experience. In the industry, we often talk about the invisible tax of complex workflows. In n8n, as soon as your logic requires conditional branching, looping, and error handling, you end up with a canvas that looks like a bowl of spaghetti. Maintaining 50+ nodes for a single logical agent is a cognitive nightmare. If you change a single JSON schema, you might have to update 10 different nodes. This is where managed agents win on developer experience, DX. In the managed agent model, the logic is defined by a concise system prompt and a set of tool definitions. It is code-centric and version controllable. As I always say in the field, if you can't read your workflow logic on one screen, you don't own the workflow owns you. Payoff: the complexity tax is real, but managed agents aren't a silver bullet. There are places where n8n still reigns supreme. Does this mean n8n is dead? Absolutely not. You have to choose the right tool for the specific constraint. n8n remains the champion of the local fortress. If you are dealing with proprietary local databases that are behind a strictly controlled corporate firewall, or if you need to connect to legacy systems via custom SSH tunnels, n8n's flexibility is unmatched. Managed agents are internet scale. They thrive when they can reach out to various cloud APIs and perform research across the web. If your task is internal data sync between a local SQL server and an on-premise ERP, stay with n8n. But if your task is intelligent market research or autonomous customer engagement, the speed and reasoning of managed agents will crush any node-based workflow. Teaser: so, how do you decide? We've arrived at the ultimate scaling strategy for your 2026 roadmap. To wrap up this head-to-head, the primary trade-off is control versus velocity. n8n gives you absolute control over every bit that moves between nodes, but it slows down your development cycle and increases maintenance overhead. Claude managed agents prioritize velocity, allowing you to deploy sophisticated, self-healing agents in a fraction of the time. As a senior developer, my advice for 2026 is simple: default to managed agents for any task requiring intelligence and judgment, and reserve n8n for plumbing and data movement. By offloading the orchestration to the AI provider, you free up your team to focus on the business logic that actually matters. Bridge: now that you understand the trade-offs, it's time to build. In the next chapter, we'll dive into the actual code for a real-world implementation. Forget the complex container orchestration or the visual spaghetti of node-based tools. Setting up a Claude-managed agent starts with simplicity. Using the Anthropic SDK, you can initialize an autonomous agent in just 5 lines of code. The shift here is moving from building a sequence to defining an intent. In the 2026 landscape, we don't map out every if-else branch. We provide the model with a set of tools and a clear objective. This snippet demonstrates how the agent is instantiated with specific capabilities like computer use or database access natively integrated. For developers, this means the infrastructure overhead of managing state and execution environments is handled entirely by the provider. It's a fundamental change in how we perceive backend automation. But as any senior developer knows, simple code often masks complex security requirements. How do we ensure this agent doesn't overstep its bounds while maintaining this level of simplicity? Next, let's look at the auth layer. The biggest friction point in n8n or Zapier is managing OAuth tokens and service accounts for every single node. Managed agents simplify this through a capabilities-based permission model. Instead of hard-coding API keys into your workflow, you grant the agent specific resource roles within your cloud environment. This process ensures that even if an agent's logic is flawed, its reach is physically limited by the identity and access management policies of the host provider. We are seeing a move toward ephemeral auth, where the agent requests short-lived tokens only when a specific tool is triggered. This drastically reduces the attack surface compared to traditional long-lived webhooks. It is the professional standard for enterprise-grade automation in 2026. But granting access is only half the battle. How do we verify that the agent is actually making the right decisions with that access? This leads us to the crucial step of pre-production debugging. Shipping an agent to production isn't like shipping a static script. Because agents are non-deterministic, your testing strategy must be robust. In the industry, we use simulation traces replaying historical data through the agent to see if its tool calling logic remains consistent. This checklist represents the bare minimum for any senior developer deploying an agent today. You must verify instruction adherence, tool call accuracy, and most importantly, graceful failure handling when an API returns a 500 error. Unlike n8n, where a node simply turns red, a managed agent can attempt to self-heal or request clarification. This resilience is what makes them superior for production use, provided you have the right guardrails in place. Once you've checked these boxes, you're ready to deploy. But where exactly should you deploy them to see the highest ROI? Let's move into the specific winning scenarios that are currently dominating the market. Scenario 1 is the death of traditional ETL pipelines. We've all dealt with messy APIs, those endpoints that change their schema without notice or return inconsistent data formats. In n8n, a single missing field can break a 20-node workflow. Claude managed agents, however, excel at autonomous synthesis. Instead of a rigid map, the agent understands the pure intent of the data. If a field name changes from user ID to id, the agent reasons through the context and maps it correctly without human intervention. This makes managed agents the perfect layer for cleaning, normalizing, and synthesizing data from disparate, unreliable sources. It's not just automation, it's an intelligent buffer that keeps your downstream systems clean. But what happens when the data isn't just sitting in an API? What if it's scattered across the live web? That's where our next scenario comes in. The second major use case is real-time market intelligence. In the past, market research meant building complex scrapers and manual CRM updates. By 2026, managed agents can browse the live web, identify competitorships or news signals, and autonomously update your CRM or internal Slack channels with prioritized insights. Unlike a simple scraper, these agents can evaluate the pure significance of a news piece. They won't just ping you when a name is mentioned. They'll analyze the sentiment and strategic impact before taking action. This level of browsing to action loop is incredibly fragile in node-based systems, but native to Claude's Agentic framework. This transforms a static database into a living, breathing intelligence asset. Now, if agents can handle market data, can they also handle our most sacred asset, our own source code? Let's look at developer-centric automation. The third scenario is one where I see the most immediate impact for engineering teams: autonomous PR reviews. By integrating managed agents directly into your GitHub Actions stack, you can move beyond simple linting. These agents don't just check for semicolons. They review the architectural implications of a pull request. They can cross-reference the new code with existing documentation and legacy patterns to flag potential technical debt or security vulnerabilities that static analysis tools miss. This is a layered approach. The agent sits between the CI runner and the human reviewer, acting as a high-fidelity filter. It reduces the cognitive load on senior developers and speeds up the deployment cycle significantly. This isn't just faster, it's a fundamentally better way to maintain code quality at scale. But let's take a step back. Why do these specific scenarios prove that the era of nodes is ending? When we look at these scenarios, ETL, market intelligence, and PR reviews, a pattern emerges. They all require high-level reasoning over unpredictable data. In node-based systems like n8n, every edge case requires a new path, leading to what I call the complexity wall. Managed agents bypass this wall by using the model's latent knowledge as the logic layer. We've seen that for tasks involving ambiguity, the ROI of using Claude directly outweighs the maintenance cost of a 100-node workflow. As we head into the later half of 2026, the question isn't whether you can build it in n8n, but whether you should. The utility is clear. Agents provide a higher level of abstraction for a lower cognitive cost, but this power comes with a major catch that most hype merchants won't tell you. We need to talk about the golden cage, the reality of vendor lock-in and the risks of putting your entire infrastructure in one provider's hands. Ready to see the dark side of this revolution? When you build inside Anthropic's ecosystem, you aren't just writing code, you're crafting high-context system prompts and model context protocol, MCP, configurations that are deeply tuned to Claude's specific reasoning patterns. If you decide to migrate to an open-source model or a different provider in 2026, you will face a significant logic translation tax. The nuanced instruction following and tool calling behaviors that make a managed agent work often break when ported to other LLMs. This creates a gravitational pull where the cost of leaving exceeds the cost of staying, even if pricing models change unfavorably. Senior architects must treat these managed agents not as universal scripts, but as proprietary firmware that is difficult to decouple. Always evaluate if your core business logic is becoming too dependent on a single vendor's black box reasoning. But lock-in isn't just about code portability. It's about who actually holds the keys to your sensitive operational data. Data residency remains the elephant in the room for enterprise AI. When using Claude managed agents, both the reasoning and the execution phases occur within Anthropic's managed infrastructure. This means sensitive PE or proprietary trade secrets are being processed and potentially cached on third-party servers. While Anthropic provides enterprise-grade security, certain industries like defense, healthcare, or high finance require data to never leave a specific geographic boundary or a private VPC. Unlike n8n, which can be deployed in a fully air-gapped environment on your own hardware, managed agents require a leap of faith in the provider's data handling policies and their resilience against regional outages. In 2026, data sovereignty is not just a legal requirement, but a competitive advantage you might lose by going fully managed. And if you thought data privacy was a risk, wait until you see how quickly an unoptimized agent loop can burn through your quarterly cloud budget. Managed agents operate on a per-token or per-run billing model, which seems cost-effective until a logic error occurs. In a recursive agentic workflow, an agent might decide it needs more information and start a loop of autonomous calls that never resolves. Without strict token quotas or circuit breaker patterns implemented at the infrastructure level, a single bug in an agent's prompt can lead to thousands of dollars in API costs in a matter of minutes. Professional developers must implement external monitoring and hard stop limits functionalities that are native to workflow managers like n8n, but are often invisible in managed agent dashboards. In 2026, agentic cost management will be a core skill for any DevOps engineer overseeing these systems to prevent runaway token inflation. This is the reality check. Autonomy is expensive if unmanaged. The risks are real, so when does the tried and true stability of a tool like n8n become the superior strategic choice? There is a hard line where managed services simply cannot cross, the air-gapped environment. For many organizations, the managed part of managed agents is a deal breaker. If your project involves local IoT devices, secure edge computing, or internal databases that are strictly forbidden from having outbound internet access, n8n remains the gold standard. By self-hosting n8n on your own servers, you maintain 100% control over the execution environment and the data flow. You aren't reliant on Anthropic's uptime or their API availability. For mission-critical infrastructure, where even a 0.1% chance of a cloud outage is unacceptable, the local-first philosophy of n8n provides a level of reliability and latency control that no managed service can currently match. It is the bedrock of sovereign automation. Reliability is one thing, but what happens when you need to connect to a legacy system that doesn't even have a modern AI-ready API? Claude is brilliant at general reasoning, but it often struggles with the last mile of integration. n8n boasts over 400 specialized nodes, many of which are maintained by a dedicated community to handle the quirks of specific legacy ERPs, CRMs, and niche SaaS tools. While a managed agent can try to use general browser tools to navigate an interface, it is often slower, more expensive, and more prone to error than a purpose-built API connector. Using a specialized node in n8n ensures that data types are handled correctly and error codes are caught precisely. If your workflow relies heavily on deep integrations with older, less AI-friendly software, n8n's robust library of connectors will save you months of prompt engineering and debugging. It's the difference between a generalist and a specialist. So, do we have to choose one or the other, or can we build a system that takes the best of both worlds? The most sophisticated architectures of 2026 aren't picking sides. They are adopting a hybrid strategy. In this model, n8n acts as the operational skeleton handling webhooks, scheduling, and reliable data transport across legacy systems. Meanwhile, the Claude managed agent acts as the cognitive brain that is called only when unstructured data needs processing or complex decisions are required. This approach limits your vendor lock-in to just the cognitive parts of the stack while keeping your integration logic portable within n8n. By using n8n to gatekeep and sanitize the data before it hits the expensive LLM, you optimize for both cost and security. This modularity is the hallmark of a senior-level AI infrastructure design. Now that we've balanced the risks and rewards, it's time to finalize our 2026 roadmap in the concluding chapter. We have reached the point of no return in modern automation. In 2026, the critical question for any architect is no longer whether AI can do the job, but where that intelligence should live. If your workflow requires 100% deterministic execution with zero variance such as financial transaction logging or strict database synchronization and remains your primary stronghold, its visual nodes provide a level of auditability that managed agents cannot yet match. However, if your project involves high-entropy data, subjective reasoning, or multi-step tool use that previously required dozens of complex if-else branches, Claude's managed agents are the clear winner. They effectively collapse technical debt by replacing rigid logic with fluid reasoning. But does this mean we abandon traditional workflows entirely? Not quite. The most successful systems I see in the field today use n8n as the skeleton for data movement while delegating the brain functions to Claude. This hybrid approach balances reliability with intelligence. But wait, how do you decide which path to take for a specific production workload? The decision matrix we are looking at now provides the final filter for your 2026 roadmap. This framework will determine if you are building a legacy system or a future-proof agentic engine. The transition from workflow-first to agent-first architecture is a fundamental paradigm shift for senior developers. In the 2026 landscape, your value isn't measured by how many APIs you can stitch together, but by how effectively you can bound and govern autonomous agents. To stay relevant, you must master the Model Context Protocol (MCP) and learn to write system prompts as code. The era of manual orchestration is slowly fading into the background of infrastructure history. By adopting a managed agent mindset today, you are essentially future-proofing your tech stack against the upcoming wave of fully autonomous software entities. Don't wait for a total system overhaul. Start small, migrate one non-critical reasoning task from a cluttered n8n workflow to a Claude managed agent, and observe the reduction in maintenance overhead. The future doesn't belong to those who merely automate tasks, but to those who successfully orchestrate intelligence at scale. Now that we have established the framework, it is time to look at the very first step you should take on your own production server tomorrow morning.